Hello, I'm Valentin. So I will talk about things I do during my free time, which is contributing to GNOME OS. And yes, the name is prêt-à-booter image. It's like prêt-à-porter, but prêt-à-booter. Yeah. This is just a live image, but there are some tricks, some nice things that I hope that people will steal from me. So let's first start with GNOME OS. I hope everybody has heard about GNOME OS, but I can just quickly talk about it. So it's a distribution that is mainly made for development and QA testing in GNOME. But this is also a distribution that we have to consider that we want to be able to install it on our machine. So many people in the GNOME OS team just use GNOME OS on their machine. And in this summer, we had also this summer of GNOME OS where we tried to gather some people to try that on their machine and use it for a summer. GNOME OS we started from scratch. We reinvented everything, how to make a distribution. But one of the things that you have to know is that it's image-based using systemd, so the view of how image-based operating system using systemd is. So we had a plan to make a nice GNOME installer that would be able to be used for other distributions. This plan is still here, but there has been some setbacks. The good news is that it's going to resume. So we'll have a nice installer. But for now, I needed to find a way to have an installer that was just a small thing that was enough for us. We used to have an image installer that was very simple, that was just booting and showing the endless installer. And that was a bit problematic because it was not a live image, so it means that you could not test GNOME OS itself. It was built with GNOME OS, but it was not the real experience. So you had to install and then you had to reboot, and then you discover that it didn't work on your machine. Also, because we had this image that was a bit different, slightly different stack, it was a bit more maintenance. For example, we use Dracut for the installer image, and we didn't want to do that anymore because we were using it only on this image and not on the main image. So that was a bit problematic. Another thing is that we had an image that contained another image that we would write down onto the disk, and that was making the installer image 4 GB. So we wanted something smaller. And last is that the installer was very simple. It was just copying a disk image onto the disk. And there's some problem with this. First, if your disk is a different block size, the GPT table has to be different. So you can't just write the image, or it's not right to do it like that. Also, you're supposed to have an ESP that is unique UUID. Otherwise, you get some problems if you have several disks with several installation of GNOME OS. That would have lots of problems. Anyway, so I wanted to remove this and just make a new live image that could do the installation. And I wanted to have just the smallest installer as possible and reusing the rest of GNOME. So first of all, let's go back a bit and think about the installation of Linux distributions. And to really simplify how it works is that we usually boot a live image, and we have some settings to do. So the locale, for example, the important thing is the language and the keyboard mapping, which is a bit where that we have to say are the keyboard mapping, but this is things that we need to do. We need to select where we have to install, and maybe we have to create some user. And then we reboot, and it works. There is different other approaches. For example, further does a bit different things where it depends more on initial setup, GNOME initial setup, where instead of creating the user before you do the reboot, you do it on the first boot, which is nice because it connects a bit more with OEM installation or factory reset and things like that. There's still a bit some interesting thing here is that the local has to be saved onto the installation. Well, you don't really have to, but if you don't want to ask again for what language you want to use, you should save it to the disk. And it's a bit weird for us because on the first boot we don't really need a disk, but that works a bit weird for us. So I was wondering, what can I do here? And also, I wanted to use initial setup and not rewrite that because it was still work that I was doing on my free time. So let's try to think about what we can do. And the thing I thought was, because we have to do initial setup, I was thinking, let's do initial setup on the live image, and then we select the disk, and we just shift into the disk, and we just continue to run from the disk at this point without rebooting. And it was actually very simple to do that. So I will come to that. But first, the whole story about making the live image. First, we need to make a hybrid ISO, and there's a reason for that. Is that the distribution is made to be able to boot on a VM, and most VMs, including GNOME boxes, they expect to have a CD-ROM, which is a bit weird. Even on RISC-V, you expected to have a virtual CD-ROM drive. There's a few things about it that is a bit annoying. Is that when you have this kind of device, is that it doesn't allow partitions. It's read-only, so you can't just add partition there. The block size is 2K, a bit weird. But we can still boot a UEFI ESP on it. So there are things that can handle this. I mean, the Dracot can help to make images that boot correctly, but it's not always. It was not working well with the idea we had of booting image made for systemd. So systemd, once it's installed, GNOME OS, once it's installed, it looks like that on your disk. So you have an ESP. This is where you have, your kernel and your bootloader. And then you have two pairs of partition for your AB partitions. And it is /USR that is read-only. And it's ROFS file system. And of course, there is the varieties that comes with it. And your data is inside a BTRFS, which is in the LUX2, which is encrypted. When we want to make the live image, we want to have it the smallest as possible, but we want to reuse a lot of part of it. And the thing is that the /USR that we make in the live image is exactly the same as the one that is on the installed partition on the installed disk. And the ESP is a bit different, so we have less things there, but it's still a kernel there. To make this image that boots with ISO, systemd-repart doesn't handle that, because all these images are made with systemd-repart. So one of the tricks I found was Well, I can make an ISO with just the ESP and look at how big it is, and then just tell the systemd-repart, make an image with the right padding, and then I've just write back the part from the ISO that was created with ZORISO-FS. And that works. But now, if I want to boot that, there's a lot of tricks to do. Is that I want to be able to mount with GPT table because systemd is working with that, and it doesn't work really with an ISO with files that you will just do a loopback device on it. But what I found was, if we just make a loopback device on the whole GPT disk, we can just scan for partitions, and everything shows up. And systemd will find all the partitions it needs, and it will, yeah. So once we have an image that can boot, we need to have an installer, and the installer does something very simple. The first thing the installer has to do is that once it's been given a disk where to install, it has to set up TPM. Oh yeah, first of all, we need a recovery key because we do some encryption. And when we are doing the installation, there's no reason why the user wouldn't wait to get the recovery key. We just need to give it as soon as we're starting the process, because they just need to find a phone to take a picture or do something. And we can do the installation while we're doing this. So this is something that systemd doesn't do because it's always expect to generate recovery key while you create things. So, but what we do, we actually generate first the recovery key, give it to the user. We do a setup of the TPM. I'm not sure this is useful, but there is some SRK setup for the SRK, and I decided to delay that in the live and just made it only during the installation. I'm not sure at this point it's useful, but it might be at some point if there is some side effect on the TPM. We'll see. An important thing is the PCR lock. We also delay everything from the live because we don't even have the ESP that is writable. So what we do when we set up the PCR lock is that we fake ESP so that it writes the credential there, and then we just take those. And then after we generate a repart configuration, and we tell repart to do most of the job. There's one thing that is missing, is that we don't really put the slash the root file system. Yet we ask to encrypt, but we just make it. And then after, once we have made everything on the disk, we have to move the live file system onto the disk. And then after, we can eject if it's a CD-ROM. There is one thing that we are missing in the installation is setting the boot entries for UEFI. Now we rely on Shim to do that. To move the data, so one thing I didn't see during the boot of the live is that instead of using a TMPFS, we create a ZRAM device, and on the ZRAM device we format as btrfs, and we use that as a root, which is in memory. So it's like a TMPFS, but with a bit more things. So as I said, we use mostly repart. There is only the data for the root file system that we don't write. We use copy blocks dev-null for now. Once we have done the repart, we just open the lux2 device, and we do a btrfs replace. Btrfs has interesting thing. It can do some read stuff, so you can add device, remove devices, and replace is just add a device, remove a device, and it just switch And you can, if you type mount and see where things are mounted, you will see that actually it has been moved. And after we have to replace, we have to resize to fill up the whole disk. Now there is another thing that we have to do is because you still can't remove the USB key because we are still using /user from the live system, from the live disk. But because we are using device mapper, this is quite easy to do that. If you don't use device mapper, as long as it's read-only, you can, for example, use DM linear or something like that and use the same trick. Which is just read the parameters for the device mapper, change the devices there, write it back, just resume, and then it works. And it doesn't use your original device, which is on your USB key. So then after you can eject. The feedback I got from users is everybody was impressed by how fast the installation was happening. Because I think the systemd-repart is probably doing the right things. I don't know. But just systemd-repart itself is doing things a bit fast. The fact also that you don't have to reboot is something quite interesting. But I had some feedback also because people didn't realize that they didn't have to reboot the machine when they installed. And everybody who has installed in Linux distributions thought that they had to reboot at that point, even though the installer didn't say anything about it. So they told me, like, well, the installer should say that you don't have to reboot this, but no, all the other installers say that you have to reboot. This one just doesn't. And someone I experienced to install with someone else who never installed a Linux, and they asked, what should we do now? And they were confused. What do you mean? Anyway. I don't know if there's any kernel developers here. There is something that I would really love to have because now we are depending on Btrfs or file system that have these red features. But what if we had a TMPFS that was just a cache onto a superblock in memory and we move the superblock onto the disk and flush onto the disk? That would be really great because we would not have to use this ZRAM thing, and we could just support X4 or anything like that. Just a quick, I don't want to do a demo. This is what this small installer does looks like. So first it says, well, you can install or you can don't install if you don't want. It asks for which do you want to install. Here there's only one. The other one is just a CD-ROM. It's installing. When it's installing, it already gives you the recovery key. You have to copy it. I think at some point we have to explain to people why they have to have a recovery key, because it's important. But then after like a few minutes, it just gives you the installation is finished. And I suggest you try it. I mean, you can try it on the VM just to see that it actually works. You can save your. You can even before installing, you can just install some app, write some document, then install, and modify the document, and try to reboot and see that the document is still there. So yeah, I hope that all the distribution will use that. Anyway, any questions?
You just said you hope other distributions will use it.
Yeah.
So what do you think would be the requirements for this to make sense?
Well, you have to be image-based, I think, because the /USR has to be. The thing is that the reason why you want to have it image-based is because you want to have a very small writable system that you can populate only during the boot, and it will go in your memory, and you don't want to take a lot of memory, and you don't want to involve overlay FS, because then it starts to be very complex, because you would have to copy all the overlay and keep it forever, and it's just not really fun. I mean, you can do that if you want, but as long as you're image-based, and your file system, your initial file system is very small, writable file system is very small, you can do that. Now, of course, now we depend on Btrfs. I would really love if we can find a way to extend it to other file system. But I don't know, maybe I'm totally wrong, and I have no idea how the kernel works for file systems. Maybe this is not possible.
If you use the system while it's installing, and let's say install an additional Flatpak with 800 megabytes of dependencies, do you see I mean, how is the usability? Do you see a slowdown? Is the system responsive? Can you do those things in parallel?
While it's installing?
Yes.
Well, first of all, the installation takes a few minutes, like 4 minutes almost. So while you are doing this, it's not. Yeah, maybe there are some slowdowns, but it's so short anyway that it's just you're not going to wait for long because the installation will be finished. The time it takes for downloading something, yeah, it's just it's very short, so that's why.
Sorry, Leonard, he was first.
How does the installer work with the user? So when you boot the live image, you have to be logged in as some user, and can you save files to the home directory of the user?
Yeah. Okay. So so you boot live, and then you get initial setup because there is no user. Initial setup will propose you to create a user and will log you in there. And then after the installer pop-ups and ask you to install. But you don't have to do the installation now. You can just you can start working and try to install things to see if things work. There's a few things that you can't do. For example, installing sysext that doesn't work yet, but Flatpaks you can install. So you can start to work on the live system to test it. And then whenever you want, you can just tell the installer to install. And then it will still, whatever you did on the memory will go onto the disk.
So my question was actually similar to Zbignev's. Like, I wonder, like, you know, if you actually put lots of data on that writable partition that is backed by ZRAM stuff, and you then replace that to move it over to the target. Like, do you get any kind of progress information from Btrfs, or how does it work? Like,
yes, I don't take it, but there is I actually do run the command to know when it's done. But usually it's in my test it's like the first call it's done. But yeah, if you have a lot of data that is in your memory, I mean you have a limit because it's just we take half of the memory and you have to fill it up. But if you have a lot of memory, yeah, sure, it will take some time, I suppose. But yeah, we can get the progress. So we could make a progress bar for that part.
Do you have to use the replace stuff, by the way? Because, you know, in repart, I always thought about, like, I wanted this atomic behavior, right? Like, so that we repartition the disk, and if you shut down the system abnormally too early, then nothing is visible on the disk, and if you do it after that point, everything hits the disk, right? But, you know, if you are replacing the backing thing, then you have this problem if the user turns off the machine at the wrong time.
No, this is a bug we have, that we need to add this feature to repart, or to have a way to tell repart, don't write the partition table yet, let me do some stuff first.
I mean, I think it would make a ton of sense to have something in repart that is not copy blocks, but copy or
yeah. The only thing is that we actually also activate the device so that it's active, so that we can because it becomes well, we have to activate the device and it has to stay alive after repart because it's there, it's mounted.
Right, but we could do that, right?
Yeah.
I don't know,
as long as we can
sounds
do that.
attractive to me to just let repart do that stuff.
Yeah.
We would leave it to you to destruct the old one, but we could set up the new one basically.
Yeah, I mean, the thing is that now there should be, we will have people working on the installer, and I think that should be one of the tasks probably to add that help, because yeah, that's one of the things, and also I mean, it would be nice to also all the PCR lock things to make it. Because PCR lock and repart are not behaving together. I would like to say that PCR lock was not run to systemd-repart yet. Just call it. I set up only the configuration. Just call it and create the credential and put it in the right place. That might be something that should also go to repart.
Okay, thank you. We have a break now from till 11:25. Thank you.